In the previous video, we talked about pressure, and if any of you have talked about or have taken high school chemistry, you're probably familiar with the formula PV equals nRT. But that formula didn't just come to be. That was the combination of several gas laws that we looked at, and various chemists back in the day looked at the relationships between pressure, volume, temperature, and the amount of the gas. So we'll start by investigating Boyle's law. And Robert Boyle was the one who investigated the relationship between the pressure of a gas and its volume. And he did these calculations and looked and investigated these properties back in the mid-1600s. So what Boyle did was he took a plot of the volume of a gas and plotted it versus its pressure. And the graph resulted in something like this. So chemists like to be able to predict things, and an exponential graph is not really good for this because it's hard to predict what's going to happen next. Okay, we like to see linear graphs, and he investigated how he could make this particular graph linear. So what Boyle did was he looked at the volume of a gas and plotted it versus 1 over the pressure. And he saw that this became a linear relationship. Linear relationships are great for chemists because we can use a simple formula like y equals mx plus b in order to determine the relationships here. So here our volume is going to equal the slope times 1 over the pressure plus our intercept. So we can say that the volume of a gas is going to be equal to some sort of constant times 1 over the pressure. Or we can say that the volume and the pressure are going to be inversely proportional. And what Boyle could say from this is that if you took the pressure times the volume, this is going to be equal to some sort of constant. After Boyle did his laws, there was someone by the name of Charles who came up with Charles's law. And in 1787, Jacques Charles found that the volume of a gas is at a constant pressure is going to increase linearly with temperature. So he went and plotted volume versus temperature and carried out a variety of experiments and found that this relationship was linear. This is great. He didn't have to manipulate things like Boyle did, but he said we can say that the volume is going to equal a constant times the temperature. Or we could say the volume over the temperature is going to equal a constant. Okay, so one of the ways we can see this experimentally is if you take a balloon and you cool it down very fast, you're going to see that the gas and the pressure in that balloon, the volume will shrink. Okay, so in Charles' law, he said that when we're looking at volume and temperature, they're going to be directly proportional. The last law we're going to look at is called Avogadro's law. And this was done in the 1800s. And what Avogadro stated was the following: equal volumes of gases at the same temperature and pressure contain equal number of particles. And this was the initial statement that Avogadro said. And what we can take from that, or how we can reword this, is we can say that the volume of a gas is directly proportional to the number of moles of gas. So we can say that volume is going to be equal to a constant times the number of moles, which we abbreviate with the small letter n. So now that we had these gas laws, which happened many years apart from each other, one in the 1600s, one in the 1700s, one in the 1800s, we're going to be able to combine these together to create the ideal gas equation, which is going to be looked at in the next video.